5.8, I go to the system, I go to my graph, 5.8, draw a line. It will hit the chip curve. Read it. Read it. That's my what? My network curve. So it will give me 2.1. I accept this. If I say verify your work mathematically, then you what? You go with this. That's what we got. VGS equal minus VGG, right? So, went back again and solved the second degree equation.
So the one we just divided both sides by one, correct?
What do you mean?
To cancel the one that's there, 1 minus the VGG over.
Yeah, but I moved this to the other side.
Okay.
Right? Solve the
Yeah.
equation.
Yeah,
I
yeah.
move this to this side, become a negative.
Okay. I got it.
And negative, that 1 minus
Okay.
0.695 is this, let's say.
Mhm.
And then that gives us what? That gives us,
So 1
we,
minus.
so what we did here, we took the square root, right?
Yes.
Yeah.
So we took the square root and isolated the square. We got this, so for VGG by isolating,
Okay. Gotcha.
right? Okay.
Now, yeah.
Let me move further into a different network. Now you certainly, I uploaded, because of this additions and whatever and stuff like that, I uploaded already the electronic assignment, okay? Under assignment, you go to the course website, right now you will see, you have only class project and assignment. You click on assignment and you'll find chapter 7 exercises. So just like that. Okay? So try to do, you could do 1 for practice. 781 is number 2, 782 is number 3. Do 1, 2, and 3. 1, 2, and 3. Okay? Nothing more than that. That's the analysis. You see my note? I hope you got it properly. We're changing value. You change values and you practice on this. And that's basically it. Even on your, you see me, I never go to the textbooks anymore. And but just because I've seen people with different, what additions you're using. So I want to just pick up something that related to the topic, okay?
What page again, Professor?
It's already on your,
Square
it's
root.
already on
Yeah,
Blackboard.
square,
One, two,
and then
three,
your minus.
Do 1, 2, and 3. It's gonna be 4 pages like that. So I get a selective problem of FETs. So this way we all be on the same page. No one say, well, what number from your text, what number from mine? Here we go. Right? Assignment is already on the Blackboard. Do 1, 2, and 3 related to fixed bias. Okay. But you see how, technically speaking, you could meet the customer's demand.
Yep.
Graphically, you just have to draw that. If I need if I need 2 milliamp, I go to 2 milliamp, hit the chip curve, read my value. No need to change anything from the network. That will guarantee what? The external voltage will guarantee this establishment. You follow me? Will guarantee that establishment. The reason it's because VGS is a constant, right? Does not depend on any internal values of the system. That's a constant, right?
So if VGG is positive in your work, then
VG, that's as a quantity, VGG 2.4, right? But you know VGG is what? The
Negative.
terminal is,
Negative.
the battery is shifted to a negative, right?
Yeah.
So the value has to be negative. So you say it has to be negative 2.4 for the system.
Which is on the graph right there.
Right. I got a 2.1 from my graph. Do I defeat the purpose you defeat the whole purpose of the graphical analysis if you want to do it that way, right? But this at least will be a reference for you. I would definitely tell the customer, look, go to do 2.4 direct, right? I don't have to, yeah.
No, but ask, so the Q1, this one is the 2.1 and 5.8 on the graph?
2.1, yes, the 5.8 that the customer wants
Right.
will produce 2.1 on my curve. Right? Will produce a VGS of 2.1, negative 2.1, right?
Mine says 2.5.
That's fine, but the ideal is 2.4. That's the ideal. So if you tell me you're off this, that's fine because this is a graphical approach, right? It has to be subject to
Some kind of
variation. It's impossible for a human to hit it right on the 100%. That's why we allow that 6%. We allow that 6% because we obviously want those 3 points on the curve to be ideal also. You're not using your own. But you might have gone a little lower than I did, right? He might have gone a little bit linearly. You're going to have to go non-linearly, correct? So that's the variations. All right, let's move into the self-buy question.
quick question. So if the customer wants it to produce at the maximum IDQ, will you remove the battery then?
Right, I remove that external because this has become 0, right? I mean, in other words, this has to move, here's your, this has to move up. That Q continue up
Okay.
until it's 0. So yes, you will remove that. You will remove this and will hit the ground. The RG will hit the ground automatically. You don't need it.
So like 1%.
Right? So that will produce a 12 milliamp, definitely. Now the problem is, what if the customer wants 13 milliamp?
Gotta change the whole system? No, chip.
Change the 15.
It's not possible for me. My physically, my chip can only produce what? 12 milliamp, right? So now you could do, you stay all year long, go to the lab and you could spend, you might need to reincarnate 2 times. And you will still never get that 13 milliamp, right? Which is not possible. The system, no matter how far you push it, is not gonna produce. You follow me? So now you have to think of what?
Another chip.
Alternative. The alternative is you change the chip. You might use FET with a different what? Different IDSS level. So you purchase the 15 milliamp chip. Take the chip, put it box, all set. I'll do the same analysis. Because you're not going to be able to produce that value, ID that value from internal parts, right? Okay. The self-bias, on the other hand, so for fixed bias, what is the network curve equation? Fixed bias, network curve. Network curve always VGS, okay? Network always VGS equation. Self. Self-bias. So the circuit the N R G R R S. Okay, so again the chip curve we all know. Here you go. That's my chip, right? The network curve. Which is what would be VGS. Again, this is my what? RG will be shorted, and this system will look like this. This is our what? VGS. The current are ID going through. So you get an ID right here. So you could, if you take a reference point, we could write VGS plus the voltage level right here plus V, this is RS, V RS, the sum of the voltage equal to 0, right? And the equal to 0. So we got VGS plus VRS equal to 0. Therefore, we could claim that VGS equal to minus VRS, the voltage across RS, and the voltage across RS is actually what? ID. So VGS equal minus ID R RS minus ID RS. So that's making, I mean, and if you're comparing this to
Fixed points.
right now, this is ID, that's a variable, and that's the variable, right?
Yeah.
The I is actually the Y. So how do you make these transitions between electronic and mathematics? You know that this is equivalent to what? This is as if we have X equal minus Y RS, right? If the V is on the x-axis and the I, remember, ID VGS, right? So the VGS is actually the X value, and the ID is the Y value, isn't it? So now, as if I have this equation, but normally function is always written with respect to Y. So I could claim that Y equal to what? Y equal minus 1 over RS, right? X. As if this is Y equal MX. Y equal MX. But the slope is negative, isn't it? The slope is negative. And so if you compare this to Y equal MX plus B, that's a linear line, but passes through the origin, right? 0. Y equal MX plus B is something like this. That's the B value, right?
Yes.
Maybe. I got some indicators to tell me that I do have some, I'm not talking about calculus background. Mr. Tellis, you're taking with us, or what are you, who's taking with me this semester of life? Raise your hand. Now you, he finished that. Okay. Muhammad.
Yeah, I'm doing it.
Okay, so this is, in reality, that's the equations. What does it represent? Represents something like this. If I do the comparison, the V is the X and the I is the Y, RS, then I solve for Y is -1, I divide by R, -1 RS, so this is the slope. The slope of the line, it's negative, so the network has no choice but to be something like this. I mean, it could be anywhere, right? But they all have to cross the
0.
0, 0. Who is responsible for this different levels of orientations?
In that one.
RS, right? RS, right there. Okay, so now, based on that, this is my chip, this is my network, and then you do just like you did before. You get your what? You get your ID, you get your IDQ and BGSQ. Now, the analysis, once you find this Q value, we have to go back again to our terminal. VG, VD, VS, VDS. VG, VD, VS, VDS. So, you could see from the work, that's my VG. So you could see my VG equal to, so automatically my VG equal to what? To 0, right? My VG equal to 0, and RG will act like a short circuit. RG will act like a short circuit. Follow me? Okay, so analysis. VG will equal to
0.
0. VS right here, right? Right. So because this goes to 0, right? So now at that point, that's my VS. So VS will equal to what? ID, or equal VRS. So VS equal to VRS, which is IDQ, right? RS. You have to use, once you find your IDQ and VGSQ, you're going to have to use them in the analysis, right? Okay, so VS is this, and your VD at this point, is VDD minus,
VRD.
so VD equal to VDD minus
IDQ.
IDQ
RD.
RD. Leave us with VDS, which is VD minus VS. Well, VD I have VDD minus IDQ RD. minus
IDQRS.
minus. Right? Minus VS, and VS is IDQ RS. We take IDQ as a common factor,
RD plus RS.
minus IDQ. That leaves us with what? RD plus RS. So finally, we get what? We get those 1 and those. This is what I mean analysis. Analyze the network. So you say, from the graphical approach, we will produce what? The IDQ and what? BGSQ. Examples. Suppose, you can look at some examples. So suppose PD give a value. I'll use the red to put the values on the system to see if there is any way. Get some values. Here you go. I'll use that one. 20, 3.3 on K, and 8, and VP is minus 6, just for the sake of analysis. Values, I mean orange, this could be any value. Huge, has to be a huge value, okay? Meg. Okay.
Is that 10 meg or 1 meg?
1 meg. 3.3K, 1K, 8 milliamp minus 6, VDD is 20, and no, for my case, I don't go like the textbook. Determine VDS, right? The whole 9 yards. You know me from AC, correct? Whole 9 yards. When you analyze everything. Because most of the work I'm looking at these homework or whatever. Determine the Q value of the network. There is a reason for the Q value. So this way you could get the IDQ, and of the IDQ is used to calculate the terminal values. Okay, so this way you answer everything's 100%. Chip curve, same principle, 3 points, right, Mr. Eric?
Yes.
3 point, the first point is
8.
8, so I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. Try this also on your notes. So this way you, you test it against you. And even though you're going to be doing something in the lab next, I'll tell you exactly which one, but we'll keep it. So this is my 8 ID VGS. Minus 6. So let's say 1, 2, 3, 5, 6. Half of the distance, quarter of the distance, right? So we got 3 and 2. I don't like to put too many lines inside because there is a Q value coming, there's a curve, but at least now we have these. We're gonna go through. That's my chip curve. Now next is the network curve. Here is my network equations, right? That's my network equation. So my network equation, we know that here you go. So this is my VG and this is my ID. We know that when VG what? When VGS is 0, ID is
Max.
no, VGS is right now it's looking at this equation, Mohammed. When this is 0, right? When this is 0, ID equals 0 over RS, right? 0 over number is 0. So the first point is 0, 0. So you know that that's correspond to my first point, right? Because that's a line going through the origin. So that's my first point. Next, I could use any value. So so far is I could go with if I want to go with the 50%, 3, right? I could go with any value. 1, 2, 3. I could go with 2, for example, or go to 3 or 4. Try to any values. So if you do the 4 or the 3 or the 2, you will see yourself where you're heading. So if I do the 2 milliamp, right? I mean 2 voltage is 2. So that will be what? 2 equal minus what? Minus 2, right? Minus 2. Follow me? So then I could say ID equal to what? Minus ID. RS is 1K. So therefore ID equal to what? 2 over 1. This is volt over K. So that gives you milli, right? So that gives you what? 2 milliamp. So negative 2 volt will give you what? That's my 2 milliamp, right? So negative 2. Now I draw what? Draw my network. So this is my network. Now I read mine. That's my Q right there. That's the Q. And based on that, my Q is 1, 2. Well, for me, right here is 2.4. I'm below my curve here. So this is about what? 1, 2, 3. Here it looks like minus 2.5. So 1, 2, 3, 4, 5, 6. Minus 2.5, comma 2.4. My Q. What's his Q? Read the book. Look at his Q. Okay, The Q in the book is minus 2.6, and the other one is minus 2.6, 2.6. 2.6, 2.6. Whatever I see, right? Whatever I have. All I see is, since this is linear, R is 1. 1K, so the reading should have been what? 2 point, they should be equal. But I'm getting this. You write down, you put what you see on your curve. So I'm getting this. You follow me, Mr. Dulles? That's my Q. Once the Q, gentlemen, with the derivation, are we fine how we get the network curve? Here's my network curve. VGS equal minus IDRS. You need 2 points anyway. A minimum of 2 points to draw a line. The first obvious point is when this is 0. Can you go with the level of ID? I could say, look, the level of here is my 0, right? Can I use my ID as a reference? You can do anything you want. You know, but since the chip is voltage driven, normally the assumptions is on the voltage, right? So, and I am fixed up to -6. That's my pinch off voltage. So I could choose any value I want. I've chosen what? I've chosen 2. So -2. That gives me 2 milliamp. Where is 2 milliamp? That's my second point. That's the point of intersection on the chip, right? That's my Q value. We've done this. I go back to my equation. Therefore, VG equal 0. VS is IDQ RS, and IDQ I found it to be 2.4 multiplied by, that gives me 2.4 over voltage. VD is VDD minus IDQ RD, and that's equal to 20 minus 2.4 times RD, and RD is 3.3. That gives us what? Twenty minus 2.4 times 3.3. Thanks to my solar calculators, since nobody wants to go to work.
It's 12.08.
How much?
12.08.
12.08, and that gives us VD is 7.92 of a voltage, which makes what? VDS equal to VD minus VS. VD is 7.92 minus VS, which is 2.4, and that gives us how much?
Professor, it's
Yeah.
12.9 is the answer.
You have the
You verdict. 12.08 is the answer. 2.4 times 3.3 is.
I asked you 2.4 times 3.3.
Yeah, I gave you the answer already.
What's
So
the answer? Or 2.4 times 3.3?
That's 7.92.
7.92. Therefore,
And then
this is
12.08.
0.8. Okay. So this is now that's your VD, right?
Yes.
for VD, so that changes to 12.08 minus 2.4. So that gives us
9.6.
9.68.
68. Yes.
So VDS is 9.6. Okay? That's the terminal values, right? That's the terminal. Go ahead. Question?
So for the still flash, you always gonna do the pointing, like that?
You have to, yeah, because the other one was constant, right?
Right.
There's no need. This requires a table, at least 2 points. And the 2 points of interest are, definitely the first one is the 0, right? Because I told you this is a y equal, right? Or even from here, if I take this 0, 0 means I'm starting from here, right? From here. What would be the network? 0, 0. 0 over number is, you're solving for I. So I equal this divided by that. Next you go into the left, I picked up -2. So -2, negative with negative cancel, 2 over 1. That gives you 2 milli. And so the points are 0, 0 and -2, 2. -2, 2. That's the official on the network. The third one is
That
the
would be ID.
Q value. That's the intersection between the blue and the red, right there.
And when you get those points, VGS, Q, and ID, you analytically, like, in the diet?
You could, using the equations,
Yeah.
you could, using mathematical approach.
So we don't gotta go,
Yeah, but right now, when I say determine the Q graphically, or
okay.
you're doing it that way. Okay, there is no, the other one is just for substantiation, so to speak. You follow me, Esteban?
Yes, yes.
So. Now if we need to meet certain Q value or current value, I know I have to only what? Rotate this, correct? Only. You're gonna rotate this on the same what? Keeping the origin 0, 0 fixed. I can't play around with this because the self-bias network, 0, 0 is your fixed value. So if we need, suppose you need for 2 overs. How would you adjust the network? What would you adjust? What would you change and replace and substitute and what have you? How would you change the network or the system to produce 1, 2, 3, let's say 4 milliamp? What changes would you recommend
Just about.
for 4 milliamp? So we go with this. We change / fix, whatever, change or fix. Customer wants 4 milliamp. Your system is already in front of you. I go to what? I go to 4 milliamp right here. So 1, 2, 3, 4. That's my milliamp. I continue drawing the horizontal line. Right? Continue drawing the horizontal line. Now I have to, I know this is definitely, this is my Q, isn't it? Definitely this is my Q. So here you go. You go with the so that's a new, right? This is our new.
So the voltage here will be
Let's say,
1.5.
let's say this is 1.4, 1.5, so minus 1. So the 4 milliamp will produce what?
1.5.
Will produce about negative 1.5 volt. So I go to my equation. VGS equal minus IDQ RS, right? IDQ RS. From the graph, I'm coming up with 1.5 for that particular 4 milliamp. So equal to minus 4.0 times RS. Therefore, RS equals 1.5 divided by 4.0. That's a volt, right? That's a volt. This is milliamp. So if you want the answers in ohm, you still do what? So that's the answer in will come up in K so far. What's 1.5 divided by 4?
0.37 kilos.
0.375 kilo ohm, which is equal to 375 ohm. So what do I need to change?
RS.
I need to change RS to what? I need to change RS to 375. I reduced this from 1K to 375. So the 375 will guarantee what? The 375 ohm will guarantee the 4 milliamp. You follow? Very powerful. Very powerful features. What do I need? What do I need to change or fix? So see what it said, change or fix. So right now you're changing what? You're changing RS to 375 and you're fixing what? You're fixing RD and VDD. You follow? I didn't do anything. I only changed what? RS. This, you don't tamper with this because this is so huge to guarantee some physical. That's not to change. The RG is not to change what? Not to, not to change certain quantity, but to what? To physically make sure that the signal is going into the system. So this does not play any factors in the Q value. So imagine yourself, or I don't want to say imagine yourself, imagine the technicians is sitting down and working, adjusting RG. Doesn't factors into it. Or in this case, changing RD. There's no factors in that. You follow? The intuitive approach. Now, only by time and experience, you would expect a good technician. Sometimes we keep technicians on board. Believe me, I worked for a couple of projects with Merrimack company. I was just doing mathematical analysis for them on building networks, and they had a couple of technicians, no formal educations whatsoever. Just they worked with the company, they operate the instrumentations, and somehow they have that intuition. Now you work with with these projects first. When the engineer tells you all you need to do is you adjust RS, and something comes later on, they will make fun of someone who is working on RD. They say, let him work it. Let him go through the hassle and stuff like this. It's an unbelievable culture when it comes to engineering field. It's you either have depends on, I don't want to say depends on how lucky you are, or it depends on how how you behaving. You could either be perceived very good and you become part of the team, or your behavior might build up a barrier along with other engineers. I don't know if you know what I'm talking about. It's your attitude. Your attitude is going to dictate your lifelong performance at a company. There are some people very down to earth, right? Even though they're the head of the project management or the project leaders, down to earth. They know what they're doing, and they when they assign the project they assign multiple work for team members. They don't assign it for challenge. They assign it for the whole, for the project to be produced on time. So even if they struggle, they would go and help that individual. Yes, I did assign you to complete part of the project. When we come on Friday, 4 o'clock, you're supposed to come up with result A, result B, result C, result D, so we could take it all together. I take it home and compile the whole project. If you don't come with this project, I do come on Tuesday, I'll say, so Jose, where are you up to? Right? I don't have to wait till Friday. This is down to earth individual. He could do it without the help of the others. He could do it without the help of the others. I could sit home in 2-3 hours, I do the work. But the problem is you could